Now let's talk about two key components of the Red Hat DevOps solution, OpenShift GitOps and OpenShift Pipelines. OpenShift GitOps is providing the continuous delivery and deployment component of the solution, and OpenShift Pipelines is providing the continuous integration component of the solution. Both of these are packaged as operators, which makes it incredibly easy for users to install, upgrade, and manage these components over their life cycle of the solution. And in addition, both of these are based on popular open source upstream projects. So for example, OpenShift GitOps is based on Argo CD and OpenShift Pipelines is based on Tekton. Let's look at OpenShift GitOps first. So if I go here, you can see I've got two instances of it deployed in this cluster. One is for cluster configuration, i.e. all of the infrastructure needed for this demo. And one is for application teams. We're going to look at this one later. So let's go in and look at the cluster one first. Now with GitOps, what is happening is essentially Argo CD is acting as a reconciliation between the resources and their state stored in Git and their state as they appear on the cluster. And Argo CD is making sure that those resources are always aligned and in sync with each other. So if there's a change in Git, it automatically gets deployed on the cluster. If there's a change in the cluster, you get notified and optionally automatically remediate that change as well. And we can see this when I click on Dev Spaces. I can see a list of all of the resources that are deployed here, with many of these resources having health checks associated with them. So for example, this Dev Spaces one here, you can see there's a health check associated with it. That means Argo CD is actually monitoring the health of this resource over and above the status of whether it's synced with Git and letting me know if there's any problems in terms of the health state of that application or that resource. It also monitors whether the resource is in sync or not with as it appears in Git. And then all of these statuses get aggregated upwards into the application object as a whole. We can see here this application is healthy because all the resources that are being monitored are healthy, and synchronized with the state in Git because all of the resources in this application are synchronized with Git. If we go look at my other application here, the Vault one, we can see that this is out of sync. And we can drill in to kind of look at why this is out of sync. So if we look at it, we see there is a resource here called agent injector config. And if I click on that, we see we get a nice diff and we can see exactly what the difference is, i.e. why is this different in Git versus what's in the cluster? And I can see, for example, here, there's a long base64 encoded string here with a certificate bundle. And there's something that's different about it between the two, and hence Argo CD is flagging this. This really helps to ensure that you don't have configuration drift between clusters or between environments, really helping to make sure that you have a consistent environment across all of the application deployments that you're doing. Now, in this case here, I'm being notified of this in a manual sense, i.e. I see that it's out of sync, I deal with it. The nice thing with the operator, though, is that we do some additional integrations over and above Argo CD. So, for example, we have an integrated login with OpenShift authentication, but we also have the ability to integrate this with monitoring, and this is actually out of the box. So if I click here, for example, you can see I get a nice alert that is showing me that the Vault application is out of sync, as we saw earlier, and this will automatically be sent to any configured receiver. So if I have Slack or email configured as a receiver for OpenShift alerts, I will get that, and the ops team, dev team, or the DevOps team can then remediate this as needed. And this is obviously very proactive instead of reactive, which is what we're looking for monitoring. We also have various dashboards available as well for OpenShift GitOps. So if I click on the dashboard section, we can see we have 3 dashboards. Click on overview. I can see here instantly, how many repositories and applications are deployed. I can see the aggregate of all of my application health statuses and sync statuses. If I click into the components one, I can drill in and see the statistics around my various components, allowing me to optimize, performance tune, and troubleshoot as necessary. So this is a very brief overview of OpenShift GitOps. Let's look at pipelines next. Click on pipelines. Here we can see we have a variety of pipelines that are available. And if I click on one here, we can see a particular pipeline that we've defined. And we can see here that this pipeline is built by taking a set of discrete tasks and then organizing it into a directed graph. So if I hold my mouse over one of these tasks, you can see that each task can be made up of one or more steps. In this case, I've got Maven settings and Maven goals. And the directed graph goes from left to right in terms of execution. We can also organize our tasks in parallel for tasks that are not dependent on each other. And this allows us to have more of a optimal performance for the workflow, since we can execute these at the same time. I can also go into actions and I can edit this pipeline. So I can edit this pipeline graphically. You can also edit this in code as well if you're comfortable with YAML, but for many users that are new, it's great to be able to go in at this graphically. I can go and click on add task, type in a task name and it will look it up for me. Let's pick this one, go ahead and add it. And then you can see here, I've got a red exclamation mark indicating that this task isn't fully configured because there's a required parameter that I haven't completed as of yet. So this is great for users that are new to pipelines in terms of being able to build out pipelines from scratch or enhance an existing pipeline without necessarily having to be an expert at how this works. Now, once you've got your pipeline defined, then you can execute it. And these executions of the pipelines are pipeline runs. And we can see here that I have a variety of different pipeline runs that I previously executed. I can see the name of the pipeline run, what the status of it was, that it succeeded. I can see the task status. I've got 11 tasks that were executed successfully, when it started, and how long this particular run took. If I go down here, you can see there's a few that failed. And I can see that one successful, one task failed, and 9 were skipped because that failed one caused the pipeline to be aborted. If I drill into a pipeline, I can see the status of the individual tasks. So for example, I can see that all of these were successful because they have the green check mark next to them. I can click on one of these and I can see all the logs associated with it. So if that task hadn't executed successfully, it allows me to quickly look up and understand what the problem was and remediate it and go forward as necessary. If we go back to the pipeline, right here, I also get a metrics tab, which gives me metrics about the pipeline. And I can pick different timelines here in order to see the status of them over time. We can see here, for example, that 21 of 23 were successful, 2 failed. And then I can see the times when these ran, what the statuses of those times were. So for example, if I have some infrastructure that was down and there's a lot of failures associated with that, that could give me a tweak in terms of what the problem is. I can also see some nice bar graphs here in terms of the number of pipeline runs that were executed over time for this particular pipeline. And I can also see what the average duration was over time. Again, if there's a performance problem in the downstream system, being able to highlight when that problem is happening can be really useful. And then I get a panel here that gives me a summary of those metrics as well. Now, we also provide an overview of the pipeline metrics. Let me just change this to a week so we get some data. And this overview is across all the pipelines. Now, this is currently tech preview. It is not GA, but we wanted to highlight this capability was available in terms of understanding metrics around pipelines. This provides me a view of all of the pipelines in a particular namespace, in this case, Cool Store Dev, but I could also do it for all namespaces as well, if need be. And again, I see the total status of all the pipeline runs. In this case, 50 out of 62 were successful. I again see that graph where I can see the various statuses here. I can see that I have a bunch of failures around that point in time, which again tweaks me to maybe look at what was going on at the particular moment. I can see what the duration was for all of these pipelines in aggregate in terms of averages and maximum, etc. The total runs are, and the number of runs over time. And then I can also get a nice view down here of all of the pipelines and some summary statistics of executions for each one, or i.e. pipeline runs for each one. I can see the Cool Store build had 11 pipeline runs. Total time was 33 minutes. Average was 3 minutes. Success rate was 73%. So that is a brief overview of pipelines. However, it's important to understand that these pipelines, as I showed them right now, these are delivered either by the user creating them from scratch in the OpenShift console or delivering them through something like OpenShift GitOps onto a particular cluster. There is another option for delivering these pipelines, and that is pipelines as code. And this is really useful when you have developers that want to have an integrated pipeline capability with their source code. So for example, if I'm a developer and I'm working on a new feature and I want to quickly spin up this application in a new namespace where I'm kind of like working, it's not like a formal environment or anything, I can have a Tecton folder in here that has a embedded pipeline defined. And what this allows me to do is that every time I make a change into this Git repo, it will automatically deploy and run this pipeline as needed. And in addition to that, I also get a nice green check mark here where I can actually see the status of the pipeline against specific commits. So for example, if I go to the list of commits here, I can see that the last few ones have been successful, but there were a bunch here that failed when I was initially working on this pipeline. And if I click on one of these green check marks, I can see what the status was in terms of that it's completed successfully, what the commit was, and a comment for that commit typo, stages that were executed. And I can also then just click on this and see more detailed information, including the job information here. And if I click on the pipeline, it will actually take me to OpenShift, where I can actually see the pipeline that was executed and then drill into individual logs for the tasks as necessary. So this brings me to the end of the overview for OpenShift GitOps and pipelines, and we will continue on with the demo in the subsequent videos.